All right, so this is the second lesson of 9.3. We're going to be talking about percent yield. This is the last lesson for chapter 9. And the previous lesson we did limiting reactant. So if you remember, the limiting reactant is which ingredient, which reactant do I have that's going to be used up first and stop the reaction. Once that reactant is gone, the reaction stops. Okay, so it's kind of like when you're baking. I'm sure you all bake so much. If you have all your ingredients to make some cookies, but you're gonna make as many cookies as you can, you might have enough flour to make 5 batches of cookies, but only enough sugar to make 4. So the sugar would be your limiting reactant, okay? And so it's gonna determine you can only make 4 batches of cookies unless you go get some more of your other ingredients, sugar or whatever else you need. Today we're doing percent yield. Percent yield is a little bit easier. It is related to the limiting reactant. We're going to write down a few definitions to get started, and then we'll get into a couple of math problems. Hopefully I have resolved the issue of the lag that we had with the last video. I make no promises. Okay, so we're going to cover percent yield. So we have 3 vocabulary words that we need to cover. It's some portion of the lag, but we're still having an issue. Okay. All right, here we go. Boy, computers, guys, killing me. All right. So the percent yield, to find the percent yield, you need to know the theoretical yield and the actual yield. So the theoretical yield is the maximum amount of product that we can make. Okay, so you could be, this could actually be tied into a limiting reactant problem by asking you to first calculate, which one's the limiting reactant and how much of the product could you make, just like we did in the last lesson. So the theoretical yield is the maximum amount possible, but there's always going to be some amount that gets lost due to impurities, or you have byproducts that form, or competing reactions that actually come in. So you never actually make that amount. That's why it's theoretical. Theoretically, how much would we make from our reaction? And then the actual yield is how much do I actually get in the lab? Okay, so the actual yield should always be less than your theoretical yield. So in a percent yield problem, you would be told your actual yield. In a lab, and you're going to do at least 1% yield lab, it's how much do you actually measure that you get at the end. Okay, so it should be less than your theoretical yield. And then the percent yield is that ratio, your actual to theoretical. That is a typo. I didn't type this. I totally took it from your book. It's not my fault. Yeah, that's not spelled right. So it's the actual over the theoretical, multiply that by 100%. Okay. So you have your ratio times 100%. All right, so we are going to switch here. Let me go to let's see, I'm going to go here. All right, let's see if we have fixed the lag problem. It's going to take me a minute. There's so many steps. And it's got to connect. Goodness. Okay, so I fixed maybe the lag problem, but there's still some amount of issue here because I'm not doing real well. All right. But nope, there's still lag. That's still lag. Okay, so you should have filled in your definitions here, just in case you didn't. We'll do it now. So the theoretical is the max amount of product possible. The actual is what you actually get or measure in the lab. And then the percent yield is your actual over theoretical times 100%. Okay, so we have 2 practice problems on this page that we're going to go through kind of slowly together. And then on the back side for you on the next page, there are 4 more practice problems. And so for those, I'll have you just pause the video and you can try those on your own, and then I'll go through them real quickly. So, so percent yield don't take up quite as much room. It's a simpler equation. We will have to, in this equation, we're going to have to first figure out what the theoretical yield is because they don't tell us. So for this one, we have a compound that's used to produce stuff, and then it gives us the equation for how we can make it. Okay, so we're going to react our 36.8 grams of C6H6 with plenty of chlorine, so we know which one is the limiting reactant. And it tells us our actual yield of the C6H5Cl. And it wants the percentage yield. Okay, I stopped. All right, so I first need to figure out how much of this chlorobenzene here I would make from my 36.8 grams. C6H6. So I'm going to have to go all the way to grams because that's what I'm given here. So I need a molar mass conversion first. 12 times 6, that's the wrong button. Plus 6, 78 grams in 1 mole. And then we do our mole ratio, which just happens to be 1:1 here. And then I need to go back to moles, I need to go from moles of the chlorobenzene, the C6H5Cl. So 12 times 6 plus 5 plus chlorine is 35, 112 grams. So I do that math, so I'm going to multiply the 36.8 times the 112, divide by 78. And I get 52.8. 52.8 grams is my theoretical yield. Okay, so I know that's kind of running off the screen here. So that's my theoretical yield. And I know I maybe didn't give you a whole lot of room to write this. That's okay. I'm going to come over to the other margin to do my percent yield. Okay, so my percent yield is going to be the actual yield. Okay, and it tells me in the problem I actually get that 38.8 grams. So 38.8 grams over my theoretical yield that I just calculated, the 52.8, and multiply that by 100%. So I'm going to plug that into the calculator, 38.8 divided by 52.8. So that's going to give me a percent yield of 73.5%. Okay. So that's the basics of the percent yield. So here we had to first calculate. We used our stoichiometry, right? Doing those mole conversions. We used molar mass conversion, a mole ratio, and then another molar mass conversion to find our theoretical yield. And then based on what we're given in the problem and our theoretical yield that we calculated, we figured out the percentage yield. In the second problem type, we are, if you look at the way this problem is worded, it's a little different. Get this on the screen. This one is giving us the percentage yield, and it wants us to figure out what the theoretical yield should be. Okay. No, sorry, we're gonna have to figure out the actual yield. Okay, to do that, we'll first have to figure out the theoretical yield. Okay, so I'm going to use this to calculate my theoretical yield. And then I will use the percentage yield and my theoretical yield to figure out the actual yield. So don't be surprised if in every one of your percent yield problems, you have to calculate the theoretical yield. So we are starting with, in this case, we are using the zinc sulfide, and we are figuring out the sulfur dioxide. So first step is find the theoretical yield. Okay, so my first step, I'm going to start with what they give me, the 4897 grams of ZNS. Oops, that's a big S. So I'm going to go from grams of ZNS to moles. Okay, so that's a molar mass conversion. And then I'm going to go from moles of ZNS to moles of SO2. That's going to be a mole ratio. And then I'm going to go from moles of SO2 to grams of SO2. So again, that one's going to be a molar mass. All right, so I'm going to go and fill in my mole ratio. I have 2 to 2, which really doesn't affect my math very much. Zinc sulfide is 65 plus 32, 97 grams. SO2 is 64. I think I did that math right. Okay, so I don't need to multiply by 2, so I'm just going to divide by 2. Those go away. So my math here becomes 4897 times the 64. Divide that by 97. So my theoretical yield is 32.31. Okay. So now we have to kind of think a little bit. So remember, my percentage yield is equal to actual over theoretical times 100. I'm trying to find the actual. Okay, so what I'm going to need to do, there's a couple ways that you can do this. What I usually do is change this percentage yield, right? So what I've, if we go ahead and fill in our numbers, right? We have 86.78% is equal to the actual yield, that's what we're looking for, over 3231 grams, right? Multiply that by 100%. So if I can get rid of this 100% first, right, which is easy to do, I just change this into a decimal and that goes away, right? Okay, so if I divide both sides by 100, so 0.8678 is equal to my actual yield over 3231. Okay, 3,231 grams. It's really a lot to say. So now I can just multiply these two numbers to solve for A. So my actual yield is going to be equal to 2,804 grams. Okay, or it should be close enough. So the book gives a slightly different answer, 2,794, but that's going to be a rounding error based on the molar masses, and so that would have changed the theoretical yield just a little bit. And then this is a rounded number as well, and they don't round to the end. So 2,804 grams is totally acceptable. Okay, so there's that answer. All right, so using these two problems, the next page has you calculating. It gives you two out of the three parts that you need. So you're not having to calculate theoretical yield. It gives you that for all of them. And then it either gives you the actual or the percentage yield and wants you to find the other one. So pause the video for a second. Y'all try these four, see what you get, and then we'll come back and check. I'm going to keep working them. So to find the percentage yield for this one, we are going to do the 15 over 20 times 100%. So 15 out of 20, so this is 75%. Here we're finding the actual yield. So I have my percentage yield. I'm going to go ahead and just put it into a decimal because I know that's the first step I'm going to do. Instead of 90%, I'm going to express it as a decimal is equal to my actual yield over 1. So for this one, I should get 0.90 grams. The theoretical yield for number 5. So this one we're finding percent again, 4.75 out of 5 times the 100% gives me 95%. And then again, we're finding the actual yield, so 0.48 is equal to my actual yield over 3.45, which is 1.66 grams. Okay, so that's what you should find for each of those. All right, you have another set of practice problems that you should work on either independently or if you can do so without being real obnoxious, together. So this one walks you through it. So step A, find the theoretical yield. Step B, find the percent yield. In number 2, you'll have to first find the theoretical yield. It doesn't tell you to do that, but you have to. Okay, and probably the same for problem number 3. So you have 3 practice problems here. I'll leave an answer key. This one didn't print really well. Sorry about that, but it kind of continues on to the next line. You'll be all right. Okay, so try to do these. I'll leave an answer key and you can check them at the end of class. Your homework. Let's go look at that really fast. Your homework is a little bit of limiting reactant as well. It brings that back in just a little. I had this loaded up. So you may have to reference back to your previous notes and see what's happening with limiting reactant if you have forgotten. Oh, come on, computer. So anyway, that's what's going on there. I'm just going to stop that. So you may need to look back at the previous lesson or the notes, at least the notes for sure. Okay. So you should be getting ready for your test soon. Y'all are probably going to do, so you should have some labs to do with limiting reactant and percent yield. I don't remember what I put on the schedule, if you already did the limiting reactant or not. So start working on your reviews, send me questions. Don't wait till the last minute because I probably can't help you at the last minute. Okay. But good luck.